Enterprise applications are the backbone of modern businesses, supporting core operations, customer interactions, and strategic decision-making. These applications are complex systems that must handle vast amounts of data, support a multitude of users, and adapt to ever-changing business needs. Designing such systems is a challenging task, requiring careful consideration of various factors that impact functionality, performance, security, and long-term sustainability. A robust design is essential for ensuring that an enterprise application can meet the demands of a dynamic business environment and deliver value over time. The complexity of enterprise application design stems from the intricate interplay of technical and business requirements. These applications must be scalable to accommodate future growth, reliable to ensure business continuity, and performant to provide a seamless user experience. Security is paramount, safeguarding sensitive data from unauthorized access and cyber threats. Effective data management is crucial for handling the ever-increasing volume and variety of data generated by businesses. Integration with existing systems ensures a cohesive IT landscape, allowing for efficient data exchange and process automation. Maintainability is key for long-term sustainability, allowing for easy updates, bug fixes, and enhancements. User experience plays a crucial role in user adoption and satisfaction, requiring intuitive interfaces and efficient workflows. Compliance with industry regulations and data privacy laws is non-negotiable, ensuring legal and ethical operation. Finally, cost optimization is a crucial consideration, balancing the need for robust functionality with budget constraints. Addressing these multifaceted challenges requires a holistic design approach that considers the interconnectedness of these various factors. A well-designed enterprise application anticipates future needs, mitigates potential risks, and provides a solid foundation for business growth. It is a strategic asset that empowers organizations to streamline operations, enhance customer relationships, and gain a competitive edge in the market. By understanding the key challenges and adopting best practices in design, businesses can build robust and adaptable enterprise applications that deliver lasting value. This essay delves into the complexities of enterprise application design, exploring each of the key challenges and highlighting solutions for building successful systems. Scalability refers to the ability of an application to handle increasing workloads without compromising performance. As businesses grow and user bases expand, the demands placed on enterprise applications increase exponentially. A scalable design enables the system to accommodate this growth gracefully, ensuring that it can continue to meet user needs and business requirements as the scale of operations expands. This is crucial for avoiding bottlenecks, performance degradation, and system failures that can disrupt business operations and impact customer satisfaction. Achieving scalability requires careful planning and the adoption of architectural patterns that support distributed processing, load balancing, and resource optimization. Horizontal scaling, achieved by adding more servers to the system, is a common approach for distributing the workload across multiple machines. Vertical scaling, on the other hand, involves increasing the resources of existing servers, such as CPU, memory, and storage, to handle higher demand. The choice between these approaches depends on the specific needs of the application, the nature of the workload, and the available infrastructure. Cloud computing platforms have revolutionized scalability, offering on-demand access to computing resources that can be easily scaled up or down as needed. This elasticity allows businesses to pay only for the resources they consume, making it a cost-effective approach for handling fluctuating workloads. Microservices architecture, which breaks down applications into smaller, independent services, also enhances scalability by enabling individual services to be scaled independently, based on their specific demand patterns. This modular approach allows for greater flexibility and resilience, as the failure of one service is less likely to impact the overall application. Implementing effective monitoring and performance tuning mechanisms is crucial for ensuring that the system remains scalable as it grows. By continuously tracking key performance indicators, KPIs, such as response times, resource utilization, and error rates, administrators can identify potential bottlenecks and optimize the system for optimal performance. Automated scaling solutions triggered by predefined thresholds can dynamically adjust resources based on real-time demand, ensuring that the system remains responsive and stable, even under heavy load. Reliability is a critical aspect of enterprise application design, ensuring that the system operates consistently and without interruption. Businesses rely on these applications to perform critical functions, and any downtime can result in significant financial losses, operational disruptions, and damage to reputation. A reliable system must be resilient to failures, both hardware and software, and have mechanisms in place to recover quickly in the event of an outage. This requires careful consideration of fault tolerance, redundancy, and disaster recovery planning. Fault tolerance refers to the ability of the system to continue operating even when some of its components fail. This can be achieved through techniques such as redundancy, where multiple instances of critical components are deployed to provide backup in case of failure. Load balancing distributes workload across these redundant components, ensuring that no single point of failure can bring down the entire system. Data replication ensures that data is mirrored across multiple storage locations, protecting against data loss due to hardware failures. Disaster recovery planning is essential for mitigating the impact of major events that could disrupt operations, such as natural disasters or cyber attacks. This involves establishing backup and recovery procedures, identifying alternative processing sites, and regularly testing recovery plans to ensure their effectiveness. Cloud-based disaster recovery solutions offer a cost-effective and scalable approach for ensuring business continuity, providing on-demand access to infrastructure and services that can be rapidly deployed in case of an outage. Implementing robust monitoring and alerting systems is crucial for detecting and responding to potential issues before they escalate into major failures. Real-time monitoring of system health, performance metrics, and security events allows administrators to identify anomalies and take corrective actions promptly. Automated failover mechanisms can automatically switch to backup components in case of a failure, minimizing downtime and ensuring service continuity. Regular testing and maintenance procedures are essential for validating system reliability and identifying potential weaknesses that need to be addressed. Performance is a critical factor in user satisfaction and productivity, as users expect enterprise applications to be responsive and efficient. Slow loading times, sluggish interfaces, and frequent errors can lead to frustration, reduced productivity, and ultimately, user abandonment. Optimizing performance requires a holistic approach that considers all aspects of the system, from the underlying infrastructure to the application code and the user interface. This involves identifying and addressing performance bottlenecks, streamlining data access and processing, and optimizing code for efficiency. Efficient data access is crucial for performance, as database queries can significantly impact response times. Optimizing database schema design, indexing strategies, and query execution plans can dramatically improve data retrieval speeds. Caching frequently accessed data in memory can reduce the need for repeated database queries, further enhancing performance. Load balancing distributes workload across multiple servers, preventing any single server from becoming overloaded and ensuring that requests are processed efficiently. Code optimization plays a crucial role in performance, as inefficient code can lead to slow execution and resource consumption. Profiling tools can identify performance bottlenecks in the code, allowing developers to focus their optimization efforts on the most critical areas. Minimizing code complexity, reducing unnecessary operations, and optimizing algorithms can significantly improve execution speed. Using efficient data structures and algorithms can further enhance performance by minimizing memory usage and processing time. Optimizing the user interface is essential for providing a seamless and responsive user experience. Minimizing page load times, streamlining navigation, and using efficient rendering techniques can improve perceived performance and enhance user satisfaction. Asynchronous operations, such as background loading and lazy loading, can prevent the user interface from becoming unresponsive while waiting for data or processes to complete. Regular performance testing and monitoring are essential for identifying and addressing performance issues, ensuring that the application remains responsive and efficient as usage patterns evolve. Security is paramount in enterprise application design, as these systems often handle sensitive data, including customer information, financial records, and intellectual property. Protecting this data from unauthorized access, theft, and manipulation is essential for maintaining customer trust, complying with regulations, and safeguarding the reputation of the business. A robust security design must encompass multiple layers of protection, addressing vulnerabilities at the application, network, and data levels. This involves implementing authentication and authorization mechanisms, encryption protocols, intrusion detection systems, and vulnerability management processes. Authentication verifies the identity of users attempting to access the application, while authorization determines the level of access granted to authenticated users based on their roles and permissions. Strong password policies, multi-factor authentication, and biometric authentication methods enhance security by making it more difficult for unauthorized users to gain access. Encryption protects data both in transit and at rest, preventing unauthorized access to sensitive information even if it is intercepted or compromised. Secure communication protocols such as HTTPS ensure that data transmitted over the network is encrypted and protected from eavesdropping. Intrusion detection systems, IDS, monitor network traffic and system activity for suspicious patterns that may indicate an attack. These systems can detect and alert administrators to potential security breaches, allowing for prompt response and mitigation. Vulnerability management involves regularly scanning the application and its dependencies for known security vulnerabilities, patching these vulnerabilities promptly, and staying abreast of emerging threats. Secure coding practices are crucial for preventing common vulnerabilities, such as SQL injection and cross-site scripting, that can be exploited by attackers. Security awareness training for developers, administrators, and users is essential for fostering a security-conscious culture within the organization. Educating users about common security threats, best practices for password management, and the importance of reporting suspicious activity can significantly reduce the risk of security breaches. Regular security audits and penetration testing can identify vulnerabilities and weaknesses in the system, allowing for proactive remediation and improvement of the overall security posture. A comprehensive security strategy that encompasses these various aspects is crucial for safeguarding valuable data and maintaining the integrity of the enterprise application. Data is the lifeblood of modern businesses, and enterprise applications are tasked with managing vast amounts of data generated from various sources. This data deluge presents significant challenges in terms of storage, processing, retrieval, and analysis. Effective data management is crucial for ensuring data quality, consistency, accessibility, and security. This involves implementing robust data models, efficient data storage and retrieval mechanisms, data integration processes, and data governance policies. A well-defined data model provides a structured representation of the data, defining the entities, attributes, and relationships within the data domain. This model serves as the foundation for database design, data integration, and application development. Choosing the appropriate database technology is crucial for efficient data storage and retrieval. Relational databases excel at structured data, while NoSQL databases offer flexibility for handling unstructured and semi-structured data. Data warehousing solutions provide a centralized repository for historical data, enabling comprehensive analysis and reporting. Data integration involves combining data from various sources, ensuring consistency and eliminating redundancy. Extract, transform, load, ETL processes are commonly used to extract data from source systems, transform it into a consistent format, and load it into the target data repository. Data quality management ensures that data is accurate, complete, and consistent. This involves implementing data validation rules, data cleansing processes, and data quality monitoring mechanisms. Data governance establishes policies and procedures for data access, usage, and security, ensuring that data is managed responsibly and ethically. Data mining and analytics techniques extract valuable insights from the data, enabling businesses to understand trends, identify patterns, and make better informed decisions. Big data technologies, such as Hadoop and Spark, provide the infrastructure for handling massive datasets, enabling efficient processing and analysis of large volumes of data. Data visualization tools present data in a clear and concise manner, making it easier to understand complex datasets and communicate insights effectively. Effective data management is an ongoing process that requires continuous adaptation and improvement as the volume and complexity of data increase. A well-designed enterprise application anticipates future needs, mitigates potential risks, and provides a solid foundation for business growth. It is a strategic asset that empowers organizations to streamline operations, enhance customer relationships, and gain a competitive edge in the market. By understanding the key challenges and adopting best practices in design, businesses can build robust and adaptable enterprise applications that deliver lasting value. This essay delves into the complexities of enterprise application design, exploring each of the key challenges and highlighting solutions for building successful systems.